I give you Patrick Gorong.
Good afternoon, everyone. My name is Patrick Marnifen Gorong. I come from the island of Yap, Micronesia. Currently attend the University of Hawaii, Hilo. And for the past month and a half, I've been conducting my project here in the forest streams in Las Cruces with the help of my awesome mentor, Dr. Frank Camacho from the University of Guam. And yeah, my study is on primary productivity in pre-montane forest streams, looking to compare algal growth rates between primary forest and abandoned pasture land. So, to start off with my background information, I'd like to talk about the river continuum concept, which by now you guys should all be experts on after two other of my fellow interns have already did their model on this. But just to briefly summarize the main points of the river continuum concept, it was proposed by Bano et al. In 1980, and it's the model that I used to base this experiment on. The model states that communities and streams that are closer to headwaters and have more canopy cover will be mainly shredder based. So they will have higher leaf input into the rivers, low light, so then there will be less autotrophy going on and more heterotrophic processes. So shredders who are breaking down the leaves, and that's where the carbon input into the stream comes from. So it's mainly heterotrophic. It has a P to R ratio less than 1. So production is less than respiration. And an example, this is an example that I thought was primary forest, because it has high canopy cover and low stream light. And the RCC also states that communities and streams with high levels of radiation, so low canopy cover, streams from like 4 and down, will be mainly like scraper and grazer based. So the streams are more autotrophic. There's a production to respiration ratio of greater than 1. So there's more primary production going on through, and the communities, it's grazer and scraper communities, things that focus on eating and grazing algal growth that's on rocks in the substrate. And what I thought was this, in comparison to this forest, would be an abandoned pasture land. It has open canopy, a lot of light, and the substrate matches what is proposed in this river continuum concept. So my initial observations when I first got here to Las Cruces, I saw that there was low observable algal growth in Cerro Creek. So that is my site that is found within a primary forest. I saw low algal growth, and Cerro Creek also had observable abundance in fine particulate organic matter. So it had a lot of FPOM, which is shredded leaves and organic matter that comes from the riparian areas. And Culver Creek, which is the site that I have in the abandoned pasture land, had more observable algal growth initially. So my research question was, how does primary productivity differ among the streams with different successional ages? And that led to my hypothesis and prediction, where benthic primary productivity will be higher in abandoned pasture lands than in primary forest streams. So I predict that tiles placed in abandoned pasture streams will have higher algal growth, algal accumulation, than the tiles placed in primary forest streams. So initially, my methods was to have 48 tiles in total, 24 per site. And each site, I initially was thinking of taking into account canopy cover. So I would split I have 2 subsites with 12 tiles each, 3 pairs of control and 3 pairs of treated. Control tiles are the tiles that are just on the bottom, and it's on the benthic substrate, and it allows for grazing and access to the community that is found but then the treated tiles are raised approximately 6 centimeters off of the substrate to like discourage grazing and colonization of grazers. So then, going back, I have 2 subsites per site. My first site is Sierra Creek, and my second site is found in Band Pasture Land, which is Culver Creek. And yeah, my initial plan was to have 24 tiles from site 1, 24 tiles from site 2. And these are my tile measurements. They're small tiles with 12 by 7 centimeters, and the treated tiles, as I stated, was 6 meters off the ground. However, when I went and placed my tiles into the sites, after 10 days, when I went and checked them, there was a lot of the river was flooding. The flow rate increased because of the rains. It was during the rain season, so then I lost a lot of replicates in multiple subsites. So then I went from 48 tiles to 29. Yes, 48 tiles to 29. So then I had to consolidate both of the subsites and not look at just use canopy cover as a factor to characterize the site, and no longer look at it as a subsite. And then I consolidated the subsites and named it Site 1 and Site 2. So I also did measurements on physical and chemical factors for the 2 streams in order to have an idea of what's going on in these streams physically and chemically. So I took canopy cover readings, nitrate, phosphate, dissolved oxygen, temperature in degrees Celsius, and also pH. So, like I said, after a period of 10 days, I went and I would take a picture of the sites. Initially, I was supposed to take half of the samples back, but then with the loss of replicates, I decided to just take a picture on the field and then leave it. On the 20th day, the tiles were then collected, all of them, and then brought back for microscopic analysis. The images from the day 10 photograph capture are ranked and tested using the Kruskal-Wallis non-parametric multiple comparisons with unequal sizes test, because of my unequal sizes in sampling due to loss of replicates. And the tiles from the 20th day analysis, because I lost a lot of tiles, I just decided to use the day 10 as my image analysis, and use the 20th day to look at the tiles and what's growing on them, and to figure out if this is actually primary productivity or if it's just something else that's sticking onto the tiles. So then my results. I would like to start off by saying that this graph this is the graph of the sum of the tile ranks. So I ranked the tiles from 1 to 29, with 1 being the most observable growth and 29 being the least. So this slide is, this graph is kind of anti-intuitive. So like the lower the sum of the tile ranks, that means the more average growth. So in this table, you will see over here it states the sample means, and that's the cover treated is the first number, and then zero treated is the second number, and so on and so forth down bottom. And that shows which has the most mean growth. So with these tests, it showed that there is a significant difference between the four variables that I tested. So the main significant ones is that the zero treated tiles had significantly higher growth than both the culvert control and the culvert treated, which is not disproved, but it goes against my hypothesis. So this is among all of my physical and chemical characterization factors that I sampled. 4 of them, canopy cover, pH, nitrate, and phosphate, have no statistic significance between the two sites. They're statistically the same. The only two that showed statistical difference that was significant was temperature and dissolved oxygen. So temperature appears to be inversely correlated with dissolved oxygen. Cerro Creek had high temperature, but then low dissolved oxygen, and Culvert Creek had low temperature, but high dissolved oxygen. And there has been papers and studies that show that there is a correlation between temperature and O2, where if the temperature is lower, it has a higher chance of having more oxygen content. But I wasn't able to test this, but it appears to follow the same trend. So these are the results of my microscopic analysis. So the main ones I want to talk about is, so these are the tiles, microscopic analysis of the tiles, and these are analysis of rocks from the sites. So rock samples collected near the two sites have primary producers found that were present, green and red algae. As you can see, there's filamented algae here, and you can see some red growth on the rock. But then the tile growth was limited to biofilm consisting of low amounts of algal growth. And it was mainly algae, microbial film, polysaccharides, and other organic matter. So, like, these are my tiles, and when you look at it upon closer inspection, there's not really that much primary production going on. So, in conclusion, my results showed significant differences in biofilm coverage between Cerro and Culvert Creek. Cerro treated tiles had significantly higher mean rank coverage than both control and treated tiles in the Culvert Creek. So then my hypothesis was rejected because I thought that the Culvert Creek would have higher accumulation of growth. O2 and temperature also had significant difference between the two streams, and that was just for characterization purposes. The Cerro Creek had low O2 and high temperature levels, and the Culvert Creek had the inverse relationship. So to be clear about this, the biofilm that I analyzed from the tiles had some algae, but it was mainly microbial film, insect mucus or polysaccharides, and other organic matter. So this cannot be used as an accurate measurement of autotrophy, because the growth that is the accumulation that's going on the tiles aren't really primary production. So, but then even though that showed like it didn't provide much inference into primary production as what I wanted, it supports the inference of these streams that I'm studying being heterotrophic, because the streams as studied by my peers have shown that the P to R ratio is less than 1. So then this also supports that. For future studies, looking at this study, it can provide insight into the multiple factors that affect stream primary production, such as substrate type, flow rate, season of sampling, upland successional age, and heterotrophic community. Other things that people can look at and change in order to make this have a significant, provide a significant statistical analysis that can actually mean something when it comes to primary production in these streams. Because the thing that I saw with my project was that I lost a lot of replicates, so I didn't have that much power in making my statistical differences. So yeah, that's my project, and I would like to thank Dr. Franco Macho for being very supportive and helpful in helping me get through this project, and also Team Reference for David Wibnes and Glenn Allen Beavers for going out with me and collecting samples together. I would like to thank Barbara and Juan for hosting us here in Costa Rica and giving us a very good experience here, both scientifically and culturally. I would like to thank the interns and the TAs, most especially the mentors, for providing us support scientifically. And lastly, I would like to thank the organizations, the Las Cruces and La Selva Biological Station and staff, the Organization of Tropical Studies, National Science Foundation, and the University of Hawaii Hilo for providing me with this experience to come here and do my research. Thank you. Any questions?
So you ranked the tiles by who's most covered, who's not covered, gave them a number, and then that's how you ran your stats as towards the amount of alpha.
Yes, so I used the Percival-Wallace non-parametric test where you rank because I cannot, the growth that was going on, I saw that it wasn't mainly primary production, so I couldn't analyze it based off of I couldn't run an ANOVA test because there was no number that I could use. So I just ranked it based on coverage, and then I ran it through a Percival-Wallace test, non-parametric with different sample sizes.
And this was blinding? Or did you just oh, this one's primary, call it primary? Did you rank them blindly?
Oh, yes. So I just took, I had all of the images in one folder, and then I just ranked them using PowerPoint. So 1, 2, all the way to 29. And then I had numbers on the tiles. I don't know if you guys saw there. I had numbers on the tiles on the bottom. So then after I finished ranking them, I went and flipped them over and then assigned the number to. This one came from the control, this one was treated from coverage. And then from there, that's how I got the right numbers and I did the statistics test. Yes?
I'm wondering how losing all those tiles affected your results. Do you think the tiles you lost were in the areas where the water was moving the fastest and therefore you would have had the least and the most algae? Or?
So, the tiles that I lost, it wasn't really not only water that was moving, large amounts of sediments was also being moved around. I would set my tile in what I thought was a pool, and then I would come back, and then half of it is no longer a pool. It's the one side of the river moved over to this side. So I saw a lot of scarring going on. One good example was one of the control tiles at the 10-day mark that I took a picture of that had a lot of coverage. By the time that I went on the 20th day and got it, I knew because I had the number that was the one that had the growth, the coverage, but then it was clean because it was it had been moved and I found it half buried. So then that's why I was talking with Dr. Camacho about it, and it was something that he was saying scouring could also it's not, even if it has optimal nutrients and light source, sediments and communities that are on there can also be a very big impact on primary production and how it can grow or be limited. So in total, even though my project didn't really tell me a lot about how primary production is going on, it gave me an understanding of how the different factors that needs to be looked at in order to understand how primary production is.
Is the mom still on?
Can you say hi?
Yeah.